Assalamualaikum warahmatullahi wabarakatuh. Here I will describe three. The first material is sampling strategy. The second is analytic contamination. The third is reagent contamination. The first is about the sampling strategy. Sampling is collecting a certain volume of a water body to be studied with the smallest possible amount but still representative and still has all the same characteristics as the water body. Sampling is divided into three, namely representative sampling, transport and preservation of samples, chemical analysis of samples. The sample and all tools used must not be contaminated with residue or traces of previous samples, and also not use container made of metal, iron, bronze, brass, plastic and rubber. Make sure there is not mold or mildew in the body because it can affect the results that are read. Sampling depth according to the specific location. The bottles that will be used to take sample must be clean and have been rinsed with distilled water first. Then followed by the liquid that will be used to fill the water and dry if possible. The same applies to sampling equipment such as pipettes, pumps, and which must be clean and free from residues from the old sample, especially the growth of mold and mildew must be prevented. Contamination from metals or sampling equipment which may dissolve in the sample must be prevented. Iron, brass, bronze can be dissolved in acidic or basic water, while plastic and rubber materials can be dissolved in industrial wastewater containing organic solvent or oil and gasoline. Samples can be taken separately using a bucket, plastic or glass bottle, opened and weighted, for example, with a lead ring around the neck, tied with a rope, then put into rivers, canals, wells, and so on. Take a sample at a certain depth. A closed bottle is provided which can be opened when it reaches the desired depth. Another way is to use the can or pump that such sample from faucets can be taken with an open beaker or a bottle to be closed, depending on the analysis plan. One common way of preserving sample is the cold atmosphere. Samples are transported in an isothermic box containing ordinary ice or dry ice, CO2, and then stored in the refrigerator or freezer. Disturbances that may arise during sample storage and transport. Gases such as O2 and CO2 can be absorbed by the sample water or can disappear from the sample water into the air. Suspended and colloidal substances can form their own flux and settle so that the sample becomes different from the original state. At least the mud must be suspended again evenly prior to analysis by checking the storage bottle like substance and liquid mud, grease, oil and so on can float to the surface. The second material is about analytical contamination. Contamination is defined as the entry of an unwanted compounds into the sample during the sample pre-treatment process and during analysis. Sources of contamination in samples can be from the atmosphere, operator, equipment, air, and reagents. Contamination from the atmosphere derived from particulate trace elements on the soil surface and suspended materials in the atmosphere. The simplest way to avoid atmospheric contamination of samples is to seal the solution during preparation and analysis. Analysis can be a source of contamination of the sample to be analyzed either by direct contact or through the air. And Cl can be transferred to the sample via a respiratory operator. Thus, an cigarette smoke source of metal contamination. Human skin is reported to contain metals even in very low concentration. Masks, gloves, laboratory coats are usually worn to reduce contamination. Contamination from equipment. Pyrite is resistant to acids and bases. High silica glass, cheaper glass is more resistant to solution attack. Washing equipment using 1-to-1 glaze odor frequently used preparation equipment has a lower chance of metal contamination. Fused silica, plastic, Teflon, PVC, rubber, solder paper. The next materials or the last material is about the contamination reagent. Reagent can be useful for increasing concentration. If our concentration is not what we want, contamination from reagents can be grouped into 1. Mineral acid and ammonia. 2. Inorganic solid. 3. Organic reagent. Then 4. Organic solvent. A. Mineral acid. Most contain a certain amount of metal. Extra pure acids contain metals in very low levels, generally have a fairly expensive price. Ultra pure contains a fairly low metal concentration, but the content of some elements varies between products. Analytical reagent grade agates usually contain the metals listed in the table. B. Ammonia. Ammonia solution in water placed in a glass bottle will be contaminated by silica, aluminum, calcium, and other elements which might be caused by the attack of alkaline solution on the glass. Analytical reagent. Ammonia can contain heavy metals with fairly low concentration. This might be due to the absorption of the metal by the glass. 2. Inorganic solid. Inorganic solid with reagent quality are usually pure enough to be used directly with hot purification, but a blank control solution must be prepared. This blank solution serves to correct the effect of absorption from the solvent. If the solvent is water, then the blank is distilled water. Lead is an important metal usually found in solid HCl, NaCl, NH4NO3, and KNO3. Purification is usually by crystallization or filtration. 3. Organic are slating, reagents usually contains coordinately bonded metal. This metal usually comes from solvents or reagents used in the synthesis of ligands. Organic reagents are usually used in small quantities so that contamination can often be ignored, but caution is still necessary. For example, by using reagents as blanks. 4. Solvents or organic solvents. The metal content in organic solvent is usually relatively low, which must be wary of the presence of other organic compounds dissolved in the solvent, loss of analyte, or contamination in the stages of preparation, separation, and determination. The analyte can be lost from the sample solution by the following factors. 1. Adsorption, which can come from the container or PPA from the analyzer. 2. Volatilization or evaporation, usually determined at the time of preparation. 3. Comprecipitation or settling. So, from the presentation of the material this time, if there are errors in reading or pronunciation, I apologize profusely. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.